Hello everyone, Jeff with the Green Review. Plant processes respond to temperature changes on a daily basis and on a seasonal basis. As we've already noted, many plant chemical processes speed up and slow down depending on temperature, as well as water and nutrient availability. Some plants are known to prefer cool temperatures, especially garden vegetables like broccoli, cabbage, lettuce, and spinach. Others prefer warm temperatures such as pepper, tomatoes, and melons. Seeds from plants growing in cool to cold climates usually require a specific length of cold before the seed can break its dormancy. When we want to grow these seeds, and especially if we want to start them indoors earlier than usual, we give them a cold treatment called vernalization. We mix the seeds with some damp sand, place them in jars, and place them in a refrigerator for 3 months. Bare root trees, onion sets, tulip bulbs, and other plants can be vernalized to meet their chilling requirement so that they'll flower when desired. Some seeds have a hard shell that may need a nick or scratch that will allow water to soak into the seed. This process is called scarification. Many spring blooming plants produce flower and leaf buds during the summer growing season, but these buds stay dormant until the following year. During the fall, shorter day length and colder temperatures cue the buds and the rest of the plant that was actively growing to store chemicals that act as antifreeze, so the plant can withstand freezing winter temperatures. The plants store proteins and sugars in the cells that prevent ice crystals from forming. As these chemicals are used or broken down over the winter, the buds are released from dormancy. Buds, bulbs, crowns, seeds, and roots on northern plants stay dormant until they have reached a minimum number of hours of cold, known as a chilling requirement, chilling unit, or chilling hours. After the chilling requirement is met, the plant can begin to sprout in the spring. Early spring blooming plants have a lower requirement for chilling than late spring bloomers. In fruit trees, apples have the largest chilling requirement and peaches have the lowest. Each hour the temperature is between 32 and 45 degrees is one way the chilling temperature requirement is measured, but there are several others. Fruit trees, blueberries, grapes, and nut trees all have chilling requirements that range from 100 to 1500 hours per winter. Plants located near buildings may not get as many chilling hours as plants located out in the open or at higher elevations. We often don't think about plants when the temperature is near 100 degrees, except maybe to water them. Heat stress affects plants by reducing photosynthesis, consumption of stored carbohydrates through respiration, and consumption of water stored in tree trunks. Plants in heat stress will wilt and may curl their leaves. The leaves may get dry, dead edges as water levels in the leaf drop. Stress plants will often drop many leaves, reduce the amount of root growth, and drop flowers and fruit. It can take more than 1 year for a plant to recover from one excessively hot summer. Plants that are tolerant of hot, dry conditions often have a very waxy leaf surface and may have leaf hairs that cover the surface of the leaf in a reflective silver blanket. The leaf may be thick and able to store water. On the other hand, in climates that are very dry, the leaf may just be a thorn and the stem may be modified to store water. Photosynthesis and respiration are competing chemical processes. The plant gains food and other chemicals during photosynthesis and uses them during respiration. Photosynthesis stops when temperatures are too high, but respiration increases as the temperature goes up. Even with plenty of water available, a plant may stop growing if the temperature is too hot. It will have to survive on stored food until photosynthesis can resume. So what's this mean to me? Within many species of plants, there are varieties that need less chilling hours than others. These plants can be grown farther south in areas that have milder winters. This is especially important in fruit trees. A plant with a low chill requirement may begin to grow too soon once its chill requirement is reached. If it's planted too far north, all the early growing flowers may be frozen in a late frost. Plants with a high chill requirement that are planted too far south may not receive enough hours and therefore have a difficult time releasing any buds from dormancy. Biennial vegetables such as carrots, cabbage, lettuce, and sugar beets need a cold dormancy chilling to release flower buds. If they receive too much cold in the first spring or a warm-up followed by a cooling off, they may begin to flower in the first year. And this is Jeff with a Green Review. Thanks for watching.